Let's discuss next topic of set theory. It's about relation and their properties. Relation is a subset of Cartesian product. So the definition 1, let A, B be two sets. A binary relation from A to B is a subset of A Cartesian product B. Let A contain 1, 2 and B contain A, B, C. Now A Cartesian product will contain 1A, 1B, 1C, then 2A, 2B and 2C. So relation from A to B is a subset of this. So we can take arbitrarily any subset, that will be a relation. A binary relation A to B is a set R of ordered pair where first element of each ordered pair is from set A and second element of each ordered pair come from second set B. So here you can mark one is from A and A is from B. Then 2 is from A is from B. So from that order pair, first element is from set A and second element is from set B. So we can use the notation ARB, which means AB belongs to relation R, and A not RB means AB not belongs to R. A is said to be related with B by R. So R is a relation by which A is related with B. Let's say example 1. It's about city and state relationship. Let A be a set of cities in the USA and B be a set of states in the USA. So define the relation R by specifying that AB belongs to R if city with name A is in state B. Means if city A belongs to state B, then there is a relation. So now my city Naperville, it comes under Illinois state. So you can say Naperville, Illinois is a relation. Dallas comes under Wisconsin, Chicago comes under Illinois, Middletown comes under New Jersey. So these are some relations. Like in India, we can say Mumbai comes under Maharashtra. Now example 2, let A contain 0, 1, 2, B contain AB, then 0A, 0B, 1A, 2B is a relation from A to B. So relation can also be represented graphically like functions. So this is the graphical representation of relation. Here 0 is related to 1, 0 is related to B, 1 is related to A and 2 is related to B. And we can also make a tabular representation. This is R, here 0, 1, 2, here AB. If there is a relation, you can just mark 0B related, so cross, 1A related, cross, 1B not present, so nothing, 2A not present, 2B present, so cross. So we can represent relation in graphical, also in tabular format. Just mark this relation is not a function. 0 is related with A and 0 is related with B. So this is not a function but it's a relation. So you can say every function is a relation but every relation is not a function. 0 is related with A, 0 is related with B. But f of 0 cannot be A and B. So it's not a function but it's a relation. So function as a relation, a graph of f is the set of order pair AB such that B equals to f of A, because the graph of f is a subset of A Cartesian product B. It is a relation from A to B. So for function, we can also make graph, and function is also subset of Cartesian product as relation is subset of Cartesian product. So we can say every function is relation but every relation is not function. Next, relation on set, definition 2. A relation on a set A is a relation from set A to itself. When there is a relation from a set to itself, we call as relation on a set. We can say it is a subset of A Cartesian product A. So example 3, let A be a set 1, 2, 3, 4 which order pair are in the order R equals to A divides B. So here relation is A divide B. Now I need to find the order pair where A divides B from this set A. So 1 divides 1, 1 divides 2, 1 divides 3, 1 divides 4. So 1 will be related with all 1, 2, 3, 4. Next 2 divides 2, 2 divides 4. Next 3 divides 3, 4 divides 4. So this is the relation where A divides B. These are the order pair. We can also make graphical representation for this. 1 divides 1, 2, 3 and 4. 2 divides 2 and 4. 3 divides only 3. 4 divides only 4. And this is the tabular representation. So 1 divide 1, 2, 3, 4. 2 divides 2 and 4. 3 divides only 3. 4 divides 4. So either we can write in order pair format or graphical representation or tabular representation. Example 4. How many relations are there on a set with n elements? Means it is asking how many relations possible from set A to itself where A cardinality equals to n. So a relation on a set A is subset of the Cartesian product A cross A. And how many elements A Cartesian product A contain? It contain n square elements. And if we have m element, the number of subsets possible 2 power m. Here we have n square elements. As A Cartesian product A, it contains n square elements if A cardinality equals to n. So n square element, then number of subsets possible equals to 2 power n square. So number of relations possible equals to 2 power n square if A cardinality equals to n. For example, suppose a set contain A, B, C means 3 elements. The set cardinality equals to 3. The number of relations possible equals to 2 power 3 square. It's 2 power 9. 2 power 9 is 512. So 512 relations possible on set containing A, B, C. So it's about single set. If we have two set, let's set A contain m elements, set B contain n elements. The number of relations possible from A to B. Now A Cartesian product B contain how many elements? Set A contain m, set B contain n. So m cross n. M multiplication n elements are contained in A Cartesian product B. Now how many subsets possible? So subsets possible equals to 2 power m multiplication n. So number of relations possible equals to 2 power m multiplication n. If you remember how many functions possible, so number of functions possible equals to n power m. B cardinality power A cardinality. And number of relations possible equals to 2 power m multiplication n. And if it's one set, if A cardinality equals to n, then number of relations possible from A to A equals to 2 power n square. We already proved this in this example. Now what is inverse of a relation? It's like inverse of a function. If R is a relation from A to B, then R inverse equals to BA if AB belongs to R. So here R inverse we can represent by this inverse symbol. This is for inverse. If there is a relation from A to B, then there is an inverse relation possible from B to A. So order pair will be BA. It's like inverse of a function. If f of A equals to B, then f inverse B equals to A. I already discussed function, just go through function lecture. Next, complement of a relation. It's simple. A Cartesian product B minus the relation. It's called as complement of that relation. In next lecture, I will discuss properties of relation like reflexive, symmetric, transitive. If today lecture is helpful for you, please like, share and subscribe. Thank you.